In this lecture, we would see an example of the Gram-Schmidt procedure. So actually, we are going to solve an example of the Gram-Schmidt procedure. So we would apply the Gram-Schmidt orthogonalization procedure over a set of signals, and suppose our signals are these are our signals. We have S1 of t, which is from 0 to up to 2, and the amplitude is +1. Similarly, we choose another signal S2 of t, and we say that okay, our S2 of t is a signal which is like this, from 0 up to 2. This is my S2 of t, 0 up to 2, and it has a +1 and a -1 amplitude for half a period. We can choose another signal. We suppose we have another signal S3 of t, and S3 of t is given by this one. Suppose the waveform here is for 1, and this extends up to 3. Suppose this is 3 and this one is 1, right? So suppose these are the magnitudes, the peak amplitudes given for these signal. So this is my S3 of t, and let me choose S4 of t as well. So we have S4 of t, which is given by this is t, right? S4 of t, and it is also 1 here. The peak is 1 from 0. Here also we have a 0. So we have these 4 signals, and we would apply the Gram-Schmidt procedure over these signals to get the orthonormal signals, orthonormal waveforms, right? So let's try to apply the waveform. So what we actually do, we take the first signal. In step number 1, as I explained in the previous slide, in step number 1 we would get psi1 of t, and psi1 of t we take from S1 of t, right? So we actually have psi1 of t, which we take from S1 of t by dividing the square root of its energy. So if you observe your signal, the square root of its energy, we try to find out the energy of our signal, and the energy of our signal is this integral. It exists from 0 up to 2, right? From 0 up to 2. So if I integrate it from 0 to 2, it is 1, right? dt. It is a unity. If you see your signal, it is unity. So actually your energy turns out to be 2, right? This is our energy of the signal. So if I observe my psi1 of t, if I plug this value in psi1 of t, so my psi1 of t is actually S1 of t divided by 2. This is psi1 of t. And if you want to plot it, you can plot your psi1 of t, which is the same signal S1 of t from 0 to 2, but the magnitude is half. It is divided by 2, right? So this is your psi1 of t plotted. Okay, this is our psi1 of t, the waveform, the first orthonormal basis function. We have to divide it by the square root of its energy. So this is the energy, so the square root of its energy would be here. So we would have a square root here, 1 over square root of 2, right? So this is our psi1 of t. psi 1 of t. Now we move ahead to step number 2, and in step number 2 we would actually use another signal. In step number 2 we choose another signal and we try to find out the image. We take S2 of t, right, and we try to find out the image of S2 of t. Now we choose S2 of t, and then we try to find out the image of S2 of t over the first basis function, right? So the image of S2 of t over the first basis function, over the first orthonormal signal, right, or the first orthonormal signal. And the first, if you see the second signal, is from 0 to 2, right? It exists from 0 to 2. So our limits here are from 0 to 2. Both the signals exist only from 0 to 2. So these are the limits. Now if you solve this integral, you can just split it into 2, from 0 to 1 and from 1 to 2. 0 to 1, your S2 of t is unity, right? It is 1, and psi 1 is 1 over under root 2. Your psi 1 of t is 1 over under root 2, right, dt. And if you observe from 1 to 2, if you observe from 1 to 2, the signal S2 of t is -1. It is -1, and psi 1 of t is 1 over under root 2 dt, right? This is our psi 2 of t in this 1 to 2. Now if you solve it, what actually do you get? You get 1 over under root 2 from this integral, from the first integral, and then from the second integral you would get -1 over under root 2, and it is 0, right? Actually there is no projection, which means no image of the second S2 of t over psi 1. So no image means this is already orthogonal signal. So if it was already orthogonal signal, we just need to divide it by its energy. So try to find out the energy of the signal, right? We also need to, so now you can find your d2. So if you are going step by step, you can find your d2 of t, and your d2 of t is actually S2 of t minus the image over psi 1, but this image is 0, right? 0. So our d2 of t is actually S2 of t. Now we have to find out the energy of this signal, and if you solve it for the energy of d2, it is actually the square integral of the square and integral of the square dt, and it exists from 0 to 2, right? The square only exists from 0 to 2. So if you see this one, if you integrate it, you end up with 2. So this is the energy of your signal d2. Now what the next step, what we can do, we can find our psi 2 of t now, and our psi 2 of t is d2 of t over the square root of its energy e d2, and this is actually 1 over under root 2 S2 of t, right? So it's the same S2 of t scaled by 1 over under root 2. So this is how we find our second orthonormal signal. Now we move to step number 3. Let's move to step number 3, and in step 3, what we do in step 3, we choose the third signal, right? We choose S3 of t. So if we choose S3 of t, then we have to find out the images, because now we have already psi1 of t and psi2 of t in our set, right? So we have psi1 of t and psi2 of t already in our set. So these two are already there. So we have to find the images. We have to find the image of S3 over both. Now to find the image of S3 over psi1, we call it C13, and that is S3 of t over psi1 of t, right? And now this you can see the signal S3. The signal S3 exists from 0 to 3, but the signal psi1 only exists from 0 to 2. So from 2 to 3, the product would be, this product would be 0 from 2 to 3, and our the limit of our integration is still from 0 to 2. So let me write specifically. I will write this limit because the signal present from 0 to 3. So S3 of t psi1 of t dt, right? But then you can split it into two integrals, right? You can split it into two integrals. You can say, okay, from 0 to 2 we have S3 of t psi1 of t dt, which would give us some value, and we have another, we can say there is a plus 2 to 3 S3 of t and psi1 of t dt. This would not give us value. This integral would be 0 because psi1 is 0 here, so this integral would be 0. So you would get result only from this integral. So let's solve this integral. Let's solve this integral. So the integral which we have to solve, which would give us value, is from 0 to 2. This one we are solving this integral S3 of t. But if you closely observe your signal S3, from 0 to 1 it is -1. So let's do it that way. From 0 to 1 it is -1, and our psi1 of t is 1 over under root 2, right, dt. And from 1 to 2, this signal is 1. The signal is 1, and our orthonormal signal is 1 over under root 2. So this is what we have as 1 of 3, right? Now if you observe closely this integral, from here you are getting, from the first integral we are getting -1 over under root 2, and from the second integral we are getting 1 over under root 2, and actually it is 0, which means that no image of S3 over the psi1. So C13 is actually 0. This is what we get. C13 is 0. Now we have to find another image, C23. We have to find C23, the image of S3 of t over psi2 of t. We have to find this image, right? 0 to 3. Signal is from 0 to 3. Now if we observe psi2 of t, is actually, we did not draw psi2 of t, right? and we can draw it. It is the same as s2 scaled by 1 over under root 2. So if you draw your psi 2 of t, it would look like this. Psi 2 of t, it is the same as, shape is similar to s2, but it is scaled from 0 to 2, and this is 1 over under root 2, this is minus 1 over under root 2, right? So these are the amplitudes, 1 over under root 2. Now if you solve this C23, if you try to solve this C23, the image, the projection of the third signal over the second basis function, so we can divide this, this one is 0.1, so we can divide this integral from 0 to 1, S3, this product S3 of t, 0 to 1 S3 of t is minus 1, and from 0 to 1 psi 2 of t is 1 over under root 2, right? Then you have from 1 to 2, from 1 to 2 your from 1 to 2 S3 of t, S3 of t is basically 1, right? So S3 of t is 1, and S2 of t, if you observe your psi 2, that is minus, your psi 2 is minus 1 over under root 2, right? So if you observe this integral, very interestingly, if you observe it, let's see what do we get. We get minus 1 over under root 2 from this first integral, right? And from the second integral we would get minus 1 over under root 2, right? This is what we get by solving these integrals. So what is actually, it is minus, this is the same as minus 2 over square root 2, or you can say it is equal to minus under root 2, right? It's the same. So our signal, our image C23, our image C23 is minus under root 2. So these are our images, right? C23. Now we can find D3. We can find D3. So if you try to find out D3, your D3 of it is, we have to subtract all the projection. So no projection over C13, right? We already found that C13 is 0. So we have to, let me write it, and then we have to subtract these projections. C13, psi12 minus C23 psi 2 of t. Now this one is 0, right? We already calculated this one 0. We only have this projection. So actually this is S3 of t minus square root 2 times psi 2 of t, right? And this is equal to, if you take this one, S3 of t, S3 of t plus under root 2 psi 2 of t. This is your D3 of t. Now this is your D3 of t. If you closely observe this signal, if you want to draw it, psi 2 of t, if you multiply psi 2 of t with a square root 2, you are actually getting back S2 of t. So if you are this signal, if you closely observe this one, this is the same as S2 of t. right? Because our side 2 of t is s2 of t over square root 2. So square root 2 cancel out, this cancels out, and we are left with only this one. So actually your signal, this is s3 of t plus s2 of t. Your d3 is actually the addition of these two. So if we add these three, this is the addition of this. You can draw d3, or you can, we are interested in finding out its energy, so let's find the energy of d3. Energy of d3 would be equal to the square of its integral, right? It would be the square of its integral. So 0 to 3 s3t plus s2 of t square dt, right? You can solve it like mathematically, just using that a plus b whole square, but that would be a bit lengthy. Let me do it, just try to find out d3 first and do it graphically. So it's the summation of s3 and s2. So if you sum your s3 with s2 of t, so from 0 to 1, let me graphically draw it. So I'm adding these two graphically, right? Let me draw these signals and then I'll add it. So let me draw these signals and then I'll add it. So if you observe your signal, this is the signal, my first signal, s3 of t. S3 of t is, let me draw it here, or let me do it this way. Let me draw it here so that it is clearly visible. Let me draw it here so that it is clearly visible. This one is time axis, right? So I have S3. S3 is up to 3. Minus 1 plus 1. I have S2. S2, I'll draw it here. S2 only exists from 0 to 2. It is plus 1 and minus 1 to 2, right? From 0 to 2. Plus 1, minus 1. So if you add these two, what do you get? You get your D3, right? You get your D3. It is the addition of these two. So if you add this one and this one, 0, plus 1, minus 1. So you would get a 0 here up to 1. No signal. Now this one is minus, again minus plus, so no signal here, right? No signal here. From 2 to 3 you have 1 here, 0 here, so the net result is 1. So just your signal D3 exists from 2 to 3. So if you graphically you can plot your signal, then your mathematics, your numerical, it means you have to integrate this waveform. We have to integrate this waveform from 2. This actually exists from 2 to 3, and it is the square of the signal, right? Square of the signal. It's square. So 1 square dt. We are actually integrating this one. So if you solve it, you are getting d3. So your d3 of t is actually unity between this interval 2 to 3, right? In this limit. Now once you get your d3, the energy, you can also find out its energy, right? So the you can just the energy of this signal, E of 3, d of 3. So the energy, what would be the energy of our signal? So if you see if you observe your signal d3. We have to find out psi 3. We have to find out psi 3 of t, which is actually d3 of t divided by the energy of that signal. So if you get the if you try to find out this one, the psi 3 of t, the energy is also unity if you compute that energy. So you have 1 over 1, and this is actually unity. Psi 3 of t, psi 3 of t, this energy, sorry, this is not, this one you should correct it, this is d3 of t. Energy is unity, so d3 of t over square root of 1, and you are getting d3 of t. So your psi 3 of t is actually d3 of t. Now we have to move towards finding psi 4, right? Psi 4. So let's move to find out psi 4, and for psi 4 we choose the fourth signal, right? So this is our step number 4. Choose S4 of t, and S4 of t. Now we have three basis functions, three orthonormal signals already in the set. We have already psi 1 of t, psi 2 of t, and psi 3 of t. We already have these basis function. Now it means we have to find out C14, C24, and C34. We need these to find out these three coefficients, right? C1. So let's try to find out these coefficient. C14 first. C14 first. So C14 is the image of S4 over psi 1 of t. So the image of S4, if you observe your S4, it is from 0 to 3, right? So our limits from 0 to 3, but our psi 1 is only the product will be only from 0 to 2, because our psi 1 only exists from 0 to 2. So we can split this integral from we can say that our integral limits comes out to be 0 to 2, because our psi 1 is from 0 to 2. So S4 for that period is unity, and if we observe psi 1 of t, that is 1 over square root 2 in this period, right? So we can compute this integral, and this integral is 2 over under root 2, which would give us square root of 2. So this integral would give us, if you solve it, you will get square root of 2. So the first image is here. Now we want to find C24. Try to find out C24. So C24 is the image of S4 of t over psi 2 of t. This is C24. Once again, our psi 2 of t, if you observe, psi 2 of t only exists in 0 to 2. So this would be from 0 to 2. For the rest, it would be the product would be 0. Product would be 0. So from 0 to now you can further split it. If you observe, it is from 0 to 1. Your S4 is 1, and psi 2 of t. Psi 2 of t is 1 over under root 2. Right? This is 1 over under root 2 dt. And from 1 to 2, if you observe S4, S4 is still unity, and psi 2, if you observe psi 2 of t, that is minus 1 over under root 2 dt, right? So this is our integral. Now if we solve this integral, what do you get? If you closely observe it, you are getting 1 over under root 2 from this one, the first integral, and you are getting minus 1 over under root 2 from the second integral, and this it turns out that our C24 is actually 0. C24 is actually 0. Now we have to find C34, the image of this signal. The image of this signal over the third basis function, and if you see S4 of t, S4 of t S4 of t over psi 3 of t, S4 of t over psi 3 of t dt. So now once again, if you see psi 3 of t, so our psi 3 of t only exists between 2 to 3, as we have seen above. It only exists between 2 to 3, which is 2 to 3, and it is unity. So if we this limit, the limit of integration would be from 2 to 3 only, right? So from 2 to 3, our S4 is unity, and this is also unity, 2 to 3, right? Psi 3 4. So if you integrate it, you would get 1. So C34 is 1. Now if you we have to we already have all the images. Now subtract. What we can do, we have to find out D4, right? We have to find out D4, and D4 is the subtraction of all the images C14 psi 1 of t minus C24 psi 2 of t, right, minus C34 psi 3 of t. We have to find out these. Now S4 of t, you can say is 4 of t. C14, if you go back to your side, C14 is under root 2. So we have minus square root 2 psi 1 of t, right? Square root 2 psi 1 of t. Then we have C24, and we saw that C24 is 0, so this term would be 0. So we have to subtract C34, and C34 is unity, right? So minus 1 times psi 3 of t. Now we have S4 of t minus square root 2 under root 2 psi 1 of t, psi 1 of t. If you see under root 2 psi 1 of t, this under root 2 psi 1 of t is actually S1 of t. Under root 2 times psi 1 of t is actually S1 of t. Now under root 2 times, let me write it specifically. Psi 1 of t is given by S1 of t over square root 2, right? And psi 3 of t, if you observe psi 3 of t, that is S3 of t plus S2 of t, right? So this is S3 of t plus S2 of t. It is the summation of these. So what actually you get? You get a signal. You get a signal S4 of t minus S1 of t minus S2 of t minus S3 of t. So basically you are subtracting these three signals from S4 of t. And if you do that, let's see it graphically. Let's see it graphically. You have 4 signals now. Let me plot it on the same axis, right? Let me plot it on the same axis so that we can easily subtract it. You have S4 of t. S4 of t is here, plus 1. Right? This is your S4 of t. Right? Now you have to subtract. You have to subtract the second signal. Second signal S1 of t from 0 to t. 0 to up to 2. 0 up to 2. Now we can subtract. This is your S2 of t. Sorry, this is your S1 of t. You have to subtract this S1 of t. 0 to, this is 2, 0, plus 1. Then we have to subtract. S2 of t. S2 of t is given by this value up to this plus 1 minus 1. This is 2, 3. This is S2 of t. And then we have S3 of t. And if you see, S3 of t is minus 1 here and up to 3. Minus 1 plus 1, right? And if you do this, now from 0 to 1, let's try to do it step by step. Try to do it step by step. From 0 to 1. 0 to 1, 0 to, this is 1, this is 2. 0 to 1, this is 1. So 1 minus this one, 1. So minus 1. 0 to 1, this is 1, minus 1. And this is minus 1. So minus the last one, this one, negative value. So if you observe 1, minus 1, minus 1, plus 1, you would get 0. From 0 to 1, the signal is 0, right? So from 0 to 1, this signal is 0. I can plot it here. I'll plot it in the end. Let me plot it here, right? So from 0 to 1, we got 0. Now from the second, from 1 to 2. 1 to 2, this is 1. Let me write it here, 1. 1 to 2, you have to subtract this one. This is 1, 1. To subtract this one from 0 to 1 to 2, this is minus 1. So minus 1, and this one is 1. The next one is 1. From here it is 1. So again you would get 0. 0. So this is 0 from 0 to 2. From 2 to 3. Now do it from 2 to 3. 2 to 3, 1. 1. 2 to 3, 0. Minus 0. 2 to 3, minus 0. 2 to 3, this is 1. Minus 1. So again 0. It means 0. So we do not have the fourth. What does it mean? It means that your psi 4 is actually your D4. Sorry. You are finding D4. So your D4 of t is actually 0. So if D4 is 0, it means your psi 4 of t is 0. So you only have 3 basis functions. So see, we had a set of 4 signals, S1 of t, S2 of t, S3 of t, S4 of t, non-orthogonal signals. And from here we found a set of 3 orthonormal signals: psi 1 of t, psi 2 of t, and psi 3 of t. So a set of m signals can construct n orthonormal, another set, you can form another set of n orthonormal signals which is less than equal to m. So this is what we saw in the theory, and this is how you prove it. You can also write these signals as a linear combination. You can also write these signals as a linear combination of psi 1, psi 2 and psi 3, right? Psi 1, psi 2 and psi 3. So I would leave it to you. People just try to write your signal as a linear combination. See? So if you you can use those that knowledge, the previously obtained result, your S1 of t. You can always write this as a linear combination, of all these basis function psi n of t, where your n is now from 1 to 3, and you have S1, and here you have n, right? 1n. So you have basically you can write S1 of t as S11 psi 1 of t plus S21 psi 2 of t plus S31 psi 3 of t. Right? You can write it as a linear combination of these signals, right? So if you and you already have these components S11, S21, S31. You already found these components. So just plug those values. S11 is the image of the signal over the image of this signal S1 of t over psi 1, right? You just try to find out that image. S1 over psi 1. And how you would find it? You can find S11. You can find S11 as S1t psi 1 of t dt, right? So try to find out this image which would exist from 0 to 2, because your signal exists from 0 to 2 only. And similarly, your function also exists from 0 to 2 only. So if you go back and you try to solve this integral, you can find out, you will get a value, a number. Get some number, right? You will get some number. So just try to find out this value and plug it over here. Similarly, find out this second value, plug it here. Third value, plug it here. So this would give you a S1 of t as a linear combination of these three signals. You can then you can plot it in the three-dimensional Euclidean space. This one, like this. Just put psi 1, psi 2, psi 3, and once you get this S11, S21 and S31, you can have your point in this three-dimensional space. It may be here or it may be here. Depends upon those values, whatever you get, maybe somewhere here, right? So you can get those points. Try to solve it and draw it in the Euclidean space.